Hi folks, today we're looking a little more at antiderivatives and the indefinite integral. So last class we asked ourselves, where did functions like this come from? Like we know how to differentiate 3x squared plus 2x minus 3, but what differentiates to 3x squared plus 2x minus 3? And after a little messing around we said, oh, the power must go up by 1, so maybe it'll be x squared plus x cubed minus 3x. And we could just check that by differentiating. So we get 3x squared plus 2x minus 3 when we differentiate. Got us back to the start. We must have anti-differentiated correctly. And we came up with a few little rules. One was that if we try something that doesn't work, we can just hopefully correct it. Another one is that we could always check our answer for an antiderivative. And we really shouldn't say can. We should say must always check our answer or our antiderivative by differentiating. If they don't work, we'll just fix them up. But there were also rules. So we had some common antiderivatives. If we have just a constant, it becomes that constant times x. There are really three most important rules here. There's this one, the x to the n, and then sine x and cos x. Okay. E to the x, that integrates or anti-differentiates to e to the x. 1 over x is a special case, goes to ln of absolute value of x. And that's really just some differentiation rules in reverse. But let's check out this one here, this x to the n rule. So x to the n turns into the power goes up by 1, and the flip of the new power goes in front. Okay, that's how we can anti-differentiate a power function. So if we had something like this, f of x is x to the 7, well then its antiderivative would be power goes up by 1, flip of the new power goes in front. Okay. And it doesn't get any harder if we have weirder powers. So if we had like x to the 7/3, well then its antiderivative would be the power goes up by 1, and the flip of the new power goes in front. Okay? And we could check that. We could say, what is the derivative of the antiderivative? Well, the derivative of the antiderivative should get you right back where you started. And you could see the power would come down front. 3 over 10 times 10 over 3. Oh, those just become 1. Gets you back where you started. Okay? So that's how it works with powers. The other thing that we want to be clear on is just what happens with trigonometry. So, and especially our primary trig ratios. So we know wheel of trig. We've used this to differentiate all the way through the course. Okay? But it turns out that if you go clockwise, that's going to be the same as differentiating. If you go counterclockwise, that's anti-differentiating. So let's just set up one last one here to try before we get into today's examples or today's big concept. So if I had something like f of x is, I don't know, x to the 9 plus the cosine of x. Okay, I know that the antiderivative is going to be power goes up by 1, flip of the new power goes in front. Cosine anti-differentiates to sine. I can see it right here. Okay. So its antiderivative will be sine x. And we can check this. What is the derivative of that antiderivative? Well, the coefficient would stay. We'd get 10x9. And the derivative of sine x would be cos x. In other words, we'd be back where we started, so we know we've done it right. Now, some folks noticed the last day that there actually are infinitely many functions that differentiate to this one right here. Like, if there were a plus 1 here, then it would still work. If there were a plus 2 here, then it would still work. If there were a plus pi here, it would work, right? Because the derivative of a constant is 0. And that brings us to this idea of an indefinite integral. Okay, and that begins probably the new stuff for today. So since the derivative of a constant is 0, there are actually infinitely many functions that differentiate to some f of x. The indefinite integral, which we can think of as an integral with no boundaries, it still has that fancy violin hole s. It represents all of these possibilities. It's also sometimes called the general antiderivative. Okay? So the indefinite integral, it's that integration sign we've seen before, but without boundaries. There's no a and b here. There's none of that. And if we want to evaluate an indefinite integral, it's just the antiderivative, and then we have to tack on this plus c. It's a constant. It's a constant that comes from integration. So we'll call it the constant of, wait for it, integration. Okay? And typically it's unknown. It's just that we want to represent every possible function that might differentiate to f, to regular little lowercase f. Okay? So for example, if we had the indefinite integral of 2x, okay, with respect to x, that's what you can think that dx means. Well, what differentiates to 2x? Oh, it's just x squared. Okay? But to make it an indefinite integral, we need to just tack on a plus c. So if you can do some basic antidifferentiation, and you can write the letter c, congratulations. You can also do an indefinite integral. Let's do a little practice, and hopefully I won't botch any of these. So if we have the indefinite integral of x plus 2, okay, with respect to x, all we have to do is antidifferentiate. So this is x to the 1. Its power goes up by 1. The flip of the new power goes in front. Okay. What differentiates to 2? Well, 2x. And then we put our plus c, our constant of integration. And now we can check, just like we always did. So we could check this by differentiating. So if we differentiate 1/2 x squared plus 2x plus c, what will we get? Well, we'll get a half times 2, which is just 1. Okay, the derivative of 2x would just be 2, and the derivative of c is 0. It would get us back where we started. Huzzah! It looks like we did it correctly. So every time you might as well check with differentiation, because we will always be better at differentiation than we are at integration. All right, 2 cos x. This sounds like a job for wheel of trig. Okay, and I don't need much of it here. Sine differentiates to cos x, but cos x anti-differentiates to sine x. Just like for differentiation, coefficients stay. Okay, so they're still there in the answer. So this is going to be 2 sine x. That would be the antiderivative, plus c. Let's check it. The derivative, 2 would stay. Derivative of sine x is cos x. Derivative of c is 0. Gets us back where we started. Yay! If we want to move down the chain, so if we're at f of x, you differentiate downward towards f prime, okay, and f double prime. You anti-differentiate upwards. And if we want all of the functions that differentiate to regular old f, they would be the indefinite integral of f of x or the antiderivative plus c. Okay? So example 3 says, find all functions f of x such that their derivative is this. Okay? Let's find them. F is just going to be the integral, which is almost the same as the antiderivative of f prime. So that would be the integral of 1/2 plus 3x squared minus 4/5 x cubed. 4/5 x cubed. Okay, dx. And the dx is just basically telling us with respect to x here. Okay, what differentiates to 1/2? Well, 1/2 x. What differentiates to 3x squared? I bet a lot of people can just see that by inspection, but if not, we can still use our rules. The 3 would stay, it's a coefficient. The power goes up by 1, and the flip of the new power goes in front. I think the last one is a little sneakier, so I am going to use my rules. The 4/5 will stay. Power on x goes up by 1, and the flip of that new power goes in front. And then don't forget that constant of integration, plus c. Okay. I can just clean this up. 1/2 x plus x cubed minus 1/5 x to the 4 plus c. Okay. That should be all the kind of functions f that differentiate to that derivative we're given. Let's just check by differentiating. Check. Okay, I'd get a half. I'd get 3x squared. I'd get minus 4 would come down front, and the power would go down by 1. And that c would differentiate to 0. Is that what I started with? Heck yeah. Okay. So the check isn't the answer, but it's a way to figure out whether you're correct. Let's do this last one here that involves finding all these possible functions. Okay. So right here they give us the second derivative is 3. Okay, well, the first derivative is just going to be moving up a step. So the first derivative will be the indefinite integral of the second derivative. Okay. Or the indefinite integral of 3. Okay. What differentiates to 3? You got it, 3x, and then we plus c. Okay. And if you wanted to skip straight from here to here, that's fine with me. Now we've got to go up another step. So if you want to find regular old f, well, that's going to be the integral of the derivative. Okay. Integrals, or anti-differentiation, send us up a step on the chain. And we'll just evaluate this. So f of x would be, okay, 3 stays, power goes up by 1, flip of the new power in front. What differentiates to c? Well, cx would. And now we're going to need a new constant of integration. Okay, we could call it d, you could call it c2, whatever you like. So we get 3 over 2 x squared plus cx plus d. And we can double check this. If we differentiate from that, we'd get f prime is 3x squared plus c. Sorry, not 3x squared. Boo. 3x plus c. And differentiate again. You get f double prime is 3. And that kind of makes sense. Like, the only kind of curve that has a constant concavity is a parabola. And the only thing that really determines the concavity of the parabola is the coefficient on x squared. We can show that through calculus here. Moving on. Okay. So we don't have exactly a product quotient or chain rules for integration, though there are analogs to them that we won't get to in this course this year. We can rewrite stuff in easy to integrate form. And we've been through this gag many times before. It's hard to deal with this. Well, let's just FOIL it out. That would give us 2x squared plus 6x minus 1x, so that's plus 5x minus 3. Oh, that's easy to deal with. Okay, so coefficient stays, power goes up by 1, flip of the new power in front. Coefficient stays, power goes up by 1, flip of the new power in front. Negative 3 comes from a 3x, and then a constant of integration. Okay, and lastly, we'll clean up. Now, I gotta tell you, I did a silly thing here. I am doing this video without an answer key. I usually have one with me, just because it's so annoying to make a mistake in a video, but I'm riding the razor's edge here. So I really am relying on these checks. If I check this, 3 times 3, I'll get 2x squared, okay? And then I'll get 5x, I'll get minus 3. That at least gets me to here. So I feel pretty good about this answer, okay? And you can just yell at the board in case I've made a mistake, and you can bring it all up with me tomorrow. The next one. Same sort of idea. Are there tricks that we can do here? If you have a monomial in the bottom, you can just split this up, okay, as x4 over x minus 2 root x over x. Okay. Or in other words, this is x to the power of 3. Now, you're probably already thinking x square root of x is just x to the half. That still doesn't look great. We'd still need like a quotient rule here. Okay. But notice this is a power of 1 on the bottom. Okay. When we have powers over powers, let's think of that. X to the 7 over x to the 2. Everybody simplifies that correctly as x to the 5. You just subtract your powers. What if it was x to the 2 over x to the 7? You'd do the same thing. It'd be x to the 2 minus 7 or x to the negative 5. So same thing here. If we have x to the half over x to the 1, well, we'll just subtract these two powers. Oh dear, I had the eraser on. Subtract these two powers. And so we'll get the integral of x cubed minus 2 x to the negative half. Okay. And now we're ready to integrate. They're in better form. We haven't integrated yet, so power goes up by 1, flip of the new power in front. Coefficient stays. Careful here. Power goes up by 1, flip of the new power in front. Okay, so that would be 1/4 x to the 4 minus 4x to the half plus c. Okay. And again, I'm going to check here. So that'll give me x to the 3. I'll get minus 2x. Power goes down by 1. That at least gets me to this stage. I get a little bit of confidence anyways. And again, if I've botched it, just yell at the board. Okay. One last thing. Sometimes we have a little bit of extra information, and we can deduce the value of c. So usually c is just unknown, but in a case like this one over here, f prime is 2x minus 3. All right, well, f of x is just going to be its indefinite integral. So let's just do that right away. It would be x squared minus 3x plus c. Okay, looks like c is unknown. But when x is 0, f is 3. In other words, the point 0, 3 is on f. Okay, so I can just sub in 3 for x, and 3 for y, rather, and 0 for x. And I'll figure out that in this particular case, to make it pass through that point, c has to be 3. So in other words, f of x is going to be x squared minus 3x plus 3. Okay? We can check that that passes through 0, 3 just by subbing in. We can check that it differentiates properly. Okay, it has a derivative of 2x minus 3. Yep, like it should. So this must be the curve, that particular curve. Okay. We can do that for other types of functions as well, but we need to have some extra information. So I think that this question here is pretty terrible. So let's change this next one just a little bit. Okay, let's change it so that f prime is negative sine x. Okay, and not f prime of 0 is 2, but f of, I don't know, let's say f of 0 is 5. Okay. And so we've got to find f of x. And we integrate negative sine x dx. I didn't show this step in the last one. Maybe I don't need to in this one. Looks like my computer is real unhappy. I'll come back to this in a sec. Okay, not quite sure what happened there, but that's all right. So again, I didn't show this step of finding the indefinite integral in the last one. We just went ahead and did it. If you want to do that, that's fine. Just go ahead and find it. But we're going to rely on wheel of trig. Okay. So what is the integral or antiderivative of negative sine x? Let's check it out here. I have to go counterclockwise. Oh, it's cos x. Well, that makes sense. Cos x differentiates to negative sine x. And then plus c. But we know when we put 0 in for x, that means that y is 5. So Sub in here. Let's see what we get. We get cos of 0 plus c equals 5. Now, careful here. The cosine of 0 is not 0. It's 1. Okay, so c has to be 4. Or in other words, the derivative has to be, or sorry, not the derivative, the original function has to be cos x plus 4. Okay. You can double check by differentiating. Derivative really will be negative sine x, like we expect. So that's a little walk through some indefinite integrals. There's some practice work in a sheet for you. And it looks like this. Okay. Just do the circled questions. There are answers. Okay. And there's a second side to the sheet. Right here. And it's got answers as well. Remember, if you're not sure for an antiderivative or for an indefinite integral, you just take your best guess, check it by differentiating, and then fix it up. If you finish that, or if you'd like to do some Chapter 5 test prep, here's essentially what's on the Chapter 5 test. Okay. And here are 6 questions that you could do. Okay. For the optimization problems, I'm just asking you to set them up. If you want, you can also actually do the questions. But usually most of the problems are just from the setup. And you do also have at least alleged answers here. Okay, number 4 says C Desmos for that graph. All right, folks, hope this has been helpful. Good luck with the material, and take care.